So hello everyone. So today we are going to solve the dynamic programming problem create path from CSES problem set. Right. So before starting the solution, let me introduce the generalized approach to solve the dynamic programming problem. Right. Let me, so the first step uh, that you uh, that you have to do is try or try to explore all possibilities, or we can say that all possible ways. Try to explore try to explore all possible ways. Right. In previous problems we did it, right? We have to explore all the possible ways. And the second step that we are going to do is write transition states, right? Transition states, or we can say that you have to write recurrence relation, right? The third thing, you have to define the base case. Right? By using these three steps, let's try to solve this problem, that is grid path. So you have n cross n grid whose squares may have traps. It is not allowed to move to a square with a trap. Your task is to calculate the number of paths from upper left square to the lower right square. You can only move from right. You can only move right or down. Okay. So you have the grid. So let me, yes. So you have the grid, right? Suppose I have 3 cross 3 grid. So you have to move from upper upper left corner to the bottom right corner, or we can say that square. Right, this is the upper right, upper left, this is the bottom right square. So you have to move from here to here, but you can make only move to the right or to the down, right? So you can move this, you can move this, you can move to the square this, and this is the one possible path that you can travel. This is the another possible path. So you have to explore all the path, and if you can reach here, you have to add, you have to uh, return the all possible path that you can uh, from that you can reach from here to here. You have to tell what are the number of paths that can happen. Yes. So first thing, we have to explore all paths, right? Second thing, we have to write the transition states. So what can be the transition? We can move to the uh, right, we can move to the down, right? So you can move to the right, you can move to the down. So for down, you can see that you are moved to the j plus 1. Row will remain the same, and you are moved to the j plus 1. Here, the j would remain same, you are moved to the next row, right? This is the move that you can do. And we are defining our dp ij like that. This state, current state, tells us the total number of paths, total number of paths to reach dp of ij, to reach dp of ij, right? So what I can write, right? dp of ij represents the total, hmm, let me write it clearly. dp ij represents the total number of path to reach that cell, or we can say that that square or cell, right? So from this cell, you can go to the right, or you are go to the right. So for right, we can write that dp. If you are going to move, if you are going to move right, so for right move, you have the possible paths dp of I plus 1, uh, dp of I and j plus 1, right? For the down, you are going to make transition like that. You are go to the down, right? Now for the current, that is for the current cell, that is dp of ij, the answer is going to be r plus d, right? By making the move right, how many number of path to reach ij? By making the move down, how many number of paths to reach ij? So the total number of paths is going to be r plus d, right? R plus d. So this is the transition that we do. This is the transition, right? This is the transition. Now third thing, we have to define the base case. We have to define the base case. Base case. what will be the base case? Right? Now you have to start from here, that you are on the bottom right corner, right square. How many number of paths to reach here? There is only one path, that is it is itself, right? If there is no trap, if there is no trap, if it is trap, you are going to initialize it with 0. So you have to define like that. dp of n minus 1, n minus 1 is going to be 0 if it has a trap. Otherwise, you have to initialize it with 1 if there is no trap, right? Right. So this is the base case. Suppose there is no trap, so you are going to initialize it with 1. Now you have to uh, you now you have to fill this state, right? Then you have to fill this state. For this, what can be the answer? So you can move to the down, you can move to the right. For down, you cannot move. So you have to introduce another condition, that if you are going to move down, if you are going to move down, if you are going to move down, that is you are doing I plus 1. So I plus 1 within the range. So I should be less than n minus 1. That is the condition. Then you are going to take this move. If it is not the case, you are going to the number of path from this move is going to be 0, right? So for this cell, for this cell, for this cell, d is going to be 0 and the r is going to be 1, because by making the move right, you have one path. So r is going to be 1. So the total number of path for this cell is going to be 1, right? Similarly, if you have to fill this, you can move down, you can move down, right? For down move, you have no choice. So there is no path, the answer is going to be 0. For right move, the answer is going to be 1. So the total number of paths is going to be, and you can also see that there is only one path from this cell to this cell, that is this, right? Also, there is only one path to reach from this to this, that is this, right? Now let's try to fill for this state. So when you move right, there is no path. You down, there is only one path, that is 1. So the answer for this state is going to be 1. Now this is interesting. I can assume that there is no trap. There is no trap. Now, if you from this, you can go to this, you can go to this path. So from down, there is only one path to reach here. From right, so there is only one path to reach here. So the answer is going to be 2, because when you move right, so you have one path to reach this cell. When you move down, so you have one path to reach there. So there are total 2 paths. So if there is a trap, so you are going to answer it with 0, right? So this is how you can fill your DP table, right? The answer is going to be DP of 0, 0, right? From 0, 0 to n minus 1, the number of path is going to be this, right? So this is the case. Let's try to code it. Okay. So let's try to code it. We have a n cross n grid, and we have to take the input grid of size n cross n. So for int I equals to 0, I less than n, I plus plus, same grid of I. Yes. So this is the input. So let's define the dp vector of int dp of size n, comma vector of int n. So this is our dp vector. So let's write the base case. What would be the base case? If grid of n minus 1, equals to star, if it has the if it is the character, once again. So yes, so if there is a character star, so it means there is a trap. So what we have to do, we have to initialize our dp with 0, else we can do what? dp of n minus 1, equals to 1, right? So for int, we have to traverse for some int I equals to n minus 1, I greater than equal to 0, I minus minus. For int j equals to n minus 1, j greater than equal to 0, j minus minus. Now if there is a case I equals to n minus 1, and j equals to n minus 1, so we have to continue, right? Now if there is a case that a grid of I j has a trap, then what we have to do? We have to fill dp equals to 0. Now what else case we have to make a move? We can move right, or we can move down. Now if we dp of ij equals to right plus down. Now if we are moving right, what the boundary condition we have to uh, uh, maintain that j is less than j has to be less than n minus 1, right? And If it is the case, then we can move to the right. Otherwise, the value is going to be 0. Similarly, for I has to be less than n minus 1 if we move to the down, right? Otherwise, the value is going to be 0. So this is the transition, or we can say that this is the recurrence relation. Recurrence relation. Okay. Now we have to just print construct cout dp of 0, 0, right? So this is the code. Let's check it once if there is any type mistake or not. Yes, there is no mistake. Let's try to run it. Yes, so the total number of paths is 3, right? So what is the time complexity? The time complexity is going to be complexity would be big of O n cross n, right? N cross n, because the first loop is go from 0 to n minus 1. The second loop is also going from 0 to n minus 1. So the time complexity is going to be n cross n. And the space we are going to use is and 2D vector that is of n cross n, right? So this is the space complexity. So this is the code. I hope you got this. Thanks.
Until we reach it, all you need to know is that we're holding on. We rise up from the dust and clean my throat.